Hi, this is Xinxin Pan, and today me and my team will describe what we have done for Lab 5 from EE542. So first, this lab is mainly for fast, reliable file transfer with custom TCP or IP. So we'll first set up the experimental setup, and we have done some initial experiments using AWS, and we have tested these links in AWS, which is with 10 millisecond delay, with 50 millisecond delay, with 100 millisecond delay, with 150 second delay, and with 200 millisecond delay, with loss rate 0% to 25%. And this is the result of the experiment we have done using AWS. And then for the part of improving TCP performance, we have first built the Ubuntu kernel in VirtualBox. So after we have cloned all the kernel file, and after we go through all these procedures, we have actually make modifications to these files. So for the TCP timer.c file, we first modified the timeout function. We actually using timeout equal to 2.1 multiply RTO-base instead of the original timeout function. And we also opt out this function, this backoff function. So we basically just modify the timeout function and opt out the timeout function. And next, we deleted this sentence, and we also make some changes to this. So for delayed ACK missed inflate ATO and delayed ACK missed leaving ping pong mode and deflate ATO, we basically just opt out these parts in this function. And since in this function, we basically just for each iteration will let ICSK back off +1. But in this case, we set the back off to a constant value and the retransmits to a constant value to give us a constant timeout and window size. And in this case, we set, instead of using the minimum value between these two values, we just basically use this one instead of this one. And we also use this one instead of the minimum one. So basically, we won't actually use a minimum value from this one and just keep using the same RTO value to give us a more faster transmission. We can also notice that basically we use a minimum value between these two is because that the old value might already be too high compared to the value now. So basically by making modification to the RTO value and let it use the original RTO value will give us a faster transmission. And then we're using the TCP hybrid one. So for modification, we modify the TCP sender CWND from 2 to 1. And we also make modification to the sender window size. So for the sender window size, instead of using the minimum value between these values, we just simply send this set the sender window size to the sender window size clamp, which basically is a higher value, so it will let the sender to receive more information in each packet transmission. In TCP output file, we first, for the restart window size, we modified this, which means that instead of using the minimum value between the restart window size and the window size, we'll just use the restart window size. And for this one, the TCP sender window size, instead of using the maximum between the CWND and restart window size, we'll just using the clamp window size, which basically will give us a larger window size and will make the transmission faster. And in the TCP select initial window function, we basically just determine a window scaling and initial window to offer. So based on the assumption that a given amount of space will be offered, store the results in the TP structure. So this is actually the setting, the initial window the TCP will use. So for this modification, we instead of using the minimum window clamp and space, we just simply giving the maximum between window clamp and space, which will give us a larger initial window size. And for the receiver window size, we also just using the max TCP window size, which will also give us a larger receiver window size and make the transmission faster. Since the clamp value is basically the highest value in this connection, so we'll, instead of using the minimum between these values, we'll just using its own value, which will enable us to give us a higher bound than this one and make the transmission faster. And next, for this if-else, is basically to make sure that we do not exceed the maximum possible scaled window, which actually give us some limit to the window size. So we'll comment out all these if-else lines and using to make sure that we can have higher window size. And this is the same. After we comment out this sentence and set the new window size to its own size, which we get it from here, which will allow us to use a higher window size. In this function, we'll, instead of using the minimum MSS from these values, we're just using the MS now, which will give us a higher segment storage, which will give us a larger MSS segment size and will actually enable us to get to a faster transmission. And the next one is we opt out the limit boundary. We'll just set the limit to the sender window size. And since we have received some effectively packets, so in this original one, we'll let the sender CWND might decrease. So we'll just opt out this sentence. In this case, it will not make any decrease to the sender window size, which will give us a higher transmission rate. And this sentence is basically just instead of using the other boundary, we're just using its receiver threshold. And instead of using the minimum between these two, we'll just using a higher one. And the segment size, which actually we defined as the minimum between segment size and MSS, we'll just opt out this one to use the MSS we have set in the previous function. So it will let us to have a larger segment size, which will be beneficial to our increase on the transmission rate. In the tcpconf.c file, we first modify the sender window size. Instead of using the minimum between these two values, we'll just set it to the clamp size, which will give us also a higher window size. And in this one, instead of returning the maximum between 2u and this value, we'll just using a higher value, which means that in the slow start threshold, we'll also let it use a higher window size for a faster transmission. And in this file, we just basically just keep the quick ACKs to 2. So we're not using the minimum values. And we just, in this, we also keeping it to the max value. And here we just, instead of using the minimum value, we'll just using the write memory value. And in the next, so for the slow start part, instead of cutting the window size to half, we'll just keep using the original threshold. And this one also for the grow window size, instead of letting it to slowly grow, we'll just let the threshold set to the highest, which is the clamp size of the window clamp, which is a higher size. And in here for the receiver threshold, also instead of using the minimum receiver threshold and the window clamp, we're just using the window clamp, which is just basically make it a constant higher size. And in here, also instead of using the minimum one, we're just using the clamp size. And in here, we are just setting the sender window size to the clamp, which is also a higher size than this one. And here it is also, we have set the sender window size to the clamp value, which is a higher one than this one. So basically, in this lab, all the modifications we have made is to keep the window size to a higher size. No matter when we are just trying to initial the TCP connection, or we are recovering from congestion, or we have faced in a slow start phase, or whatever phase we're in, all the modifications we have made is basically to let the receiver have a higher window size and to let the sender to have a higher window size, so that they can actually have fast file transfer rate. And since we have these, we need to develop a solution to transfer large data over a high latency lossy link. So we also, after reading all the reading materials, we also decided to opt out all the back-off algorithms, because back-off algorithms is good, but it is not really suitable for lossy link. But we actually need to perform these TCP connection in a 20% loss rate connection. So these are the modifications we have made to the kernel files.
Okay, so now we have to switch the kernels. First, we open the client server, and in the terminal, we use we have to find the kernel files. We can see there are 4 deb files here. It's the kernel we have to install. We use the command dpkgi to install all the deb files. After the installation, we just use reboot command to reboot the client and the server. Then we can see the kernel is successfully installed here. Then we have to change the congestion control protocol. First, we change it to the high blah. It's what we modified previously. Then we can start the file transfer SCP Lab5 data. Okay, so now the transfer gonna be finished. Now the transfer